Hi, this is Srinivasan, Assistant Professor ECE. In this presentation, we are going to discuss on magnitude comparator. So, what is a magnitude comparator? A magnitude comparator is a combinational circuit that compares two numbers A and B and determines their relative magnitudes. So, the output or the outcome of the magnitude comparator will be either A greater than B, A is equal to B, or A less than B. So for comparing two n-bit numbers, it has 2 to the power 2n entries in the truth table and it becomes too complex even with n is equal to 3. So we illustrate this method by deriving an algorithm for the design of a 4-bit magnitude comparator. So the algorithm is a direct application of the procedure a person uses to compare relative magnitudes of two numbers. Let us consider two numbers. A is equal to A3, A2, A1, A0. B is equal to B3, B2, B1 and B0. First we are going to generate an expression xi is equal to AI Bi plus AI dash Bi dash for I is equal to 0, 1, 2 and 3. If the two numbers A and B are equal, that can be analyzed if A3 is equal to B3, A2 is equal to B2, A1 is equal to B1, A0 is equal to B0, we can conclude A is equal to B. That can be obtained by determining x0, x1, x0, x2 and x3. So if the binary variable A is equal to B, then all x0, x1, x2 and x3 will be equal to 1, which means A is equal to B. And next we will obtain the function for A greater than B and A less than B. If A greater than B, if A3 is greater than B3, which means A3 is equal to 1, B3 is equal to 0, then we can conclude A is greater than B. So A3 is represented in full form and B3 is represented in its complement form. So A3, B3 dash. If A3 is equal to B3, then we go out to look after A2 and B2. So plus x3, A2, B2 dash. If A2 is equal to B2, then we need to move on A1, B1 plus x3, x2, A1, B1 dash. If A1 is equal to B1, then we need to go with plus x3, x2, x1, A0, B0 dash. So by using this expression, we can obtain whether A is greater than B or not. Similarly, we can obtain the expression for A less than B. So if A3 is 0 and B3 is 1, so it means A is less than B. So A3 dash B3 relates to A less than B. If A3 is equal to B3, then we move on to the next one, A2 B2. So plus x3 A2 dash B2. If A2 is equal to B2, then we need to move on to A1 B1, x3 x2 A1 dash B1. If A1 is equal to B1, then we need to move on to A0 B0. So x3 x2 x1 A0 dash and B0. The gate implementation of the three output variables is just derived. It seems that they does not involve any certain amount of repetition. The unequal outputs can use the same gates that are needed to generate the equal output. The logic diagram is as shown in figure, where we obtain x0, x1, x2 and x3, from which we obtain the three output function A less than B, A greater than B and A equal to B. And when you look at A is equal to B, it is an AND gate of x3, x2, x1 and x0. The four X outputs are generated with exclusive NOR circuits and are applied to an AND gate to give the output binary variable A is equal to B. The other two outputs use the X variables to generate the Boolean functions listed previously. So this is a multi-level implementation and have a regular pattern. So thank you.